Hello and welcome to the LMI webinar series. My name's Aaron, and today we have Nathan Funk with us to discuss the Gocator 6.1 software. He'll be going over the new features and enhancements of this exciting new software release. And before I hand it over to you, Nathan, just want to remind everyone that this is being recorded. You'll be able to watch this in a couple hours' time. Just check your email box, so don't worry about having to miss this, or if anyone is missing this right now, you'll get a chance to view this. One last thing is if you have any questions, you'll probably notice you don't have any audio capabilities. So if you could please use the chat function, you'll see it on the right-hand side of your screen. If you have any questions during this, just put a question in there in the chat and we will get to it if there is enough time. We do have some time set aside for Q&A. So without further ado, Nathan, I'll hand it over to you.
Thanks a lot, Aaron. So yeah, like Aaron was saying, this is all about the 6.1 software release. It just went out publicly today, so you will have received an email notification if you're subscribed. And yeah, I'll be introducing all the high-level features. There's still a good number of features that I won't cover that are more detailed, but you'll see all of those in the release notes, and you should be able to catch up on all those details in the manual as well. So the main features I'm going to be covering are, first of all, 360-degree inspection. I'll demonstrate mesh alignment and stitching tools a little bit as well. Then we'll talk about wide alignment. Then talk about new tools, including surface pattern matching. Sorry, that got renamed from template matching to pattern matching. And then GoHMI SDK and the G2 translucent material. So talking about 360-degree inspection first, this is really all about applications where you need to not just look at a part from the top down or only from the side, but you need to do both from top and side, for example, at the same time. You would be able to do this before 6.1 through separate setups. So you could have one sensor scanning from the top, one sensor scanning from the side, and then have them operate independently from each other. But there was no really good ability to do this in a combined way where you would scan the whole part and then be able to inspect from any direction you want previously. So this is something that we're introducing in the 6.1 firmware. And so for parts like you can see here on the right-hand side, where you've got a lot of tolerances on different sides, this is where this would really be suitable. So the challenges that we've had so far with 6.0 and earlier are just when you turn on uniform spacing, if you're familiar with that feature, it turns the received data from the sensors into a height map, which means that you're going to lose all the vertical data and overhang data, like you can see in this illustration on the right-hand side, all these red little areas. Anything there will just get lost because it's being resampled into a height map. So for every X location, there's a height value, and that simply cannot represent these vertical and overhang areas. So there's just a fundamental structure with the fundamental issue with the data structure used there. And if you turn uniform spacing off, you end up with point cloud data. So there's no height map. You're just getting point clouds. But that point cloud data is unstructured. So there's no association of the points with each other. It's just a cloud of random points. It's not easy to tell which 2 points are closest to each other. And it makes it very hard for tools to operate efficiently on this point cloud data. So it means that any tools that we would have developed here, we don't really have any currently in 6.0. They would have been very slow. So that's why in 6.1 we're changing this altogether, not using point cloud, but introducing a new data type. So currently the only measurement capability you really have when you are in point cloud mode, you turn uniform spacing off, is if you are also in profile mode, then you can have some tools that operate on this point cloud data in profile mode on a ring layout, but it's quite limited what you can do there. So the new data type that we're introducing as part of this firmware is called mesh. Really, this is what you expect it would be if you're familiar with other software packages that deal with meshes. It really is just a way of connecting points into triangles. So for every point that we receive in the point cloud, we can associate it with the nearby points through a triangle. And that entire structure of this set of points and set of triangles that connect the points is what we call the mesh. So this creates some structure from the otherwise unstructured point cloud, and it allows us to operate on the mesh much more efficiently with algorithms for measurement or whatever than we would have been able to operate on the point cloud itself. So really, this is a step forward towards more efficient processing and allowing us to create some tools that can work effectively on this 360-degree data. And like you can imagine, obviously, if you have data in the back, in this illustration on the back side of the bunny, you would be able to operate on that just as well as on the front-hand side. So we're introducing two key tools here for both alignment and the transformation. So these are two separate steps where in all the existing alignment routines that we have, it's performed on the scan page. This is actually being performed through a tool. So it is quite different from previous alignment methods. So you would add a surface align ring tool. You would take in the raw untransformed alignment data from your sensors, and that it would perform the alignment producing an XML file that gets stored on your PC. So this is operating on PC only currently. The transformation then takes this XML file, and for all subsequent data coming from the scanners, it will transform it based on the transformation determined by the alignment tool, and then also stitch it all together into a mesh. So that's what we call the surface mesh tool, and its output is a mesh. So this surface align ring tool, you would only run once to perform the alignment. And then once you've got a good XML file describing the transformation of each of your sensors, then you use that as the input into your surface mesh tool. And together with the point cloud data that's coming from all the sensors, it produces the mesh for each scan. So this surface align ring tool operates specifically on a new alignment target. We're calling it the double-sided pyramid. So it's basically two truncated pyramids, one facing upwards, one facing downwards. And you can build this depending on the size of the setup that you need to cover the field of view for. You would build this to an appropriate size, and you enter the dimensions of this into the alignment tool so it knows what to expect. But then we're using the face data from all these faces that are being scanned by each of the sensors, performing plane fits, and then getting a transformation for each of the sensors, including X and Z rotation. So this is a full 6 degree of freedom transform that's being determined from the data that is being scanned. And then once you have a mesh, so you perform the alignment, you've performed the meshing, you can now take this new mesh data type into 4 new tools: mesh template matching, mesh projection, mesh plane, and mesh bounding box. So I'll show you each of those shortly. I'm just going to quickly talk about mesh template matching. So this performs matching in full 6 degrees of freedom. So it will account for offset of the part as well as rotation in X, Y, and Z angles. And this works similarly to the other template matching tools that we have. You would perform a scan of a part in the desired orientation that you want to bring all the subsequent scans into, and then all the subsequent scans will be oriented in that same orientation. So this outputs the aligned mesh data, the orientation data of the current scan, but it also outputs deviation statistics. So there's some basic comparison that you can also perform within the tool with a minimum, maximum, and then a percentile deviation. You can set what degree accuracy you want to see these percentiles in. You could go from 25 or 10% and see where your deviations are across that distribution. So in this case, we can see our highest deviation is 80 microns, and our lowest is 33 in the opposite direction. So mesh projection is the next key tool on mesh. So this tool actually allows you to get from a mesh back into a surface height map. So this allows you to now operate on all of the with all of the existing surface mode tools. So surface hole, surface dimension, surface opening, etc., all the existing surface tools can still be used on the mesh data just by running it through this mesh projection tool. And the key thing here is that the mesh projection tool can be performed in any orientation. So you can be looking at it, it's similar to the surface transform tool in the sense that you specify what direction you want to be looking at it from, and it will generate a height map depending on that orientation that you specified. So you can take that in as a surface plane, for example, and then it will project everything onto that plane as a height map. So the key thing here is that this allows you to get from mesh to surface and then perform your surface measurements on that projected height map. So I'll just quickly share my screen here to demonstrate what these tools look like. It makes it a little bit more practical for you. There we go. So looking at the input data, this is actually looking at the unaligned data of the alignment target from multiple sensors, and it's just all overlapped with each other. So it doesn't look like much here. You can see that things are a little bit distorted, and this is because the sensors were set up with an extreme angle. So you can see these little circles here. These are actually supposed to be, or these ellipses here, these are actually circles, but they're heavily distorted just because the input data from the scanners is taken at a significant angle. So that's distorted this input data. So this is just all the data from all the sensors, and we're feeding it into the surface align tool. And the surface align tool just outputs a file. So I'm not going to show that here. It's not too interesting, but you can imagine it outputs a file and writes that to the hard drive. And then it's the the mesh stitching tool that takes in this data together with the file and outputs the mesh. So if we look at the data output from this tool, this is now a mesh, and this is the full calibration target stitched together from all the sensor data in 360 degrees. So you can even look at this data from the inside out just to show you the individual points. I don't know how well you can see this, but you can see looking from the inside out here at all the data after it's been stitched together. So this is now a full 3D model. I can also turn on the triangles. It doesn't make too much of a difference here. You can see a slight difference, sorry. And when I go inside, you just won't see all the points. They're all connected by the triangles. So just one more thing to point out, there's a difference between mesh visualization, which is just drawing these triangles, and mesh data type. These are two different things. So the mesh data type itself can be shown either as a mesh directly or as point clouds where we just do not draw the triangles. Then moving on to the next tool. This is the the mesh bounding box tool. That one's quite straightforward. It does what you would expect. You can draw a region anywhere over your part, and it will find the bounding box of the smallest bounding box around the mesh data within that region. So you can see here, this is the little piece that we had holding the alignment target, and it's finding the bounding box around that data. The mesh plane tool is quite powerful. It allows you to find a plane fit for all the data within the region of the mesh, and it allows you to also use more sophisticated outlier rejection methods than we have on the surface mode. So we can use a plane detection with the largest area, for example, maximum distance, minimum distance, eliminating outliers, or using all points like I'm showing here. So this allows you to quite robustly, even with some variation in the part orientation, fit a plane to the mesh very robustly. The output of this is just a plane feature, and you can take that into any other tool. Then moving on to the mesh projection tool. This is taking in the plane from the mesh plane tool and then outputting a surface. So if I look here on the output, this is now a height map. So you can see it was projected downward, looking from the top down. Here we are losing the side data. So you would only use this orientation if you wanted to perform some operations from the top. If you wanted to perform measurements from the side, then you would just change the transform within this tool to, for example, 90 degrees from that, or just use a different input plane to look from the side. And then you would get all the side data preserved. So you just use this, depending on the direction that you want to look from, you just take in a different input, or you add a fixed transform, and it will give you a height map from that direction. So in this case, we're looking top down. And then finally, mesh template matching, I just included that. I don't have a good demonstration of this because it requires multiple frames. I don't have that in this recording. But you can see here as well, like I discussed earlier, this tool, if you were operating on a template, would give you the XYZ offsets and the angles around XYZ, and also give you a transform mesh output that brings the input mesh into an orientation that closest match to the template. So that's it for the quick demonstration I wanted to give. I'll go back to the slides here. Just give me a second. There we go. So in here, this again is just the overview of the tools. So a total of 4 new tools around mesh, operating on mesh, and then 2 new tools for alignment and generating the mesh. Now moving on to an additional improvement that we've made around alignment. This is specifically for wide layout. So what I was talking about for mesh is expected to be used mostly with a ring layout, or any layout where you're at least expecting to see the sides. So it might not be a full 360 degrees, but 180 degrees where you're looking at the sides and you want to get side data fully intact. Wide layout, you're looking primarily from the top, and then you have your sensors side by side. So previously, we only supported 5 degrees of freedom alignment with this, and there were also accuracy limitations with that. It was all done using the moving bar alignment. The inaccuracies result in inaccuracies in your final stitched results. So you would see seams, for example, or just inaccuracies in your alignment. And so that was the limitation around the alignment accuracy itself. But then on top of that, we also had limitations in the speed with which you could perform the transformation if you did have the 5 degree of freedom alignment performed. So if you perform 5 degree of freedom alignment, it results in a small Z angle. So even if you've aligned your sensors the best you can to be perpendicular to the direction of travel, then you might still have a small Z angle. The 5-degree freedom alignment would set that Z angle, and that would engage the 6-degree of freedom transformation logic, which was significantly slower than the transformation logic that would be performed without the Z angle. So that, of course, limited the Y resolution. So as you're moving forward in the Y direction, just because we were performing a lot of processing for the transformation, it would really limit the speeds and thus limit the Y resolution. So with 6.1, we're introducing a new alignment method for the wide layout that increases the precision significantly, and also includes the full 6 degrees of freedom. So previously we didn't align for the X angle. Now we're also aligning for the X angle. So we're increasing accuracy on all the axes and also adding alignment for the X angle. And this is performed on a pyramid plate target. So similar to the ring layout alignment, we're using a truncated pyramid. So it's flat on the top, and we have multiple of these aligned in a plate together. So this would be used for a 3x3 arrangement, or sorry, not 3x3, 3-sensor layout similar to the one shown here on the left-hand side. You would have 3 sensors side by side, or staggered layout like this, and each of them would scan one column of these pyramids. And after the alignment, you get a transformation with full 6 degrees of freedom for each of these sensors. So similar to the mesh alignment, there's two tools involved in this. The first step is the alignment itself. That's performed with the surface align wide tool. So previously we were talking about the surface align ring, and this is surface align wide for wide layout. Similar to that tool, we produce a XML file as the output of the alignment, and then separately there's a transformation tool that merges the data for the regular scanning that you're doing. So you would do this once, the top portion alignment you perform once, and then the transformation is something that you would use in your regular job. So you would have the surface merge wide tool in your job to perform the transformation of the incoming raw data from each of the sensors and bring it all together into the aligned height map. So the output of this is not mesh, this is just pure height map, but the change here really is about the precision and also the speed. So comparatively, this tool operates faster than the built-in transformation operation on the scan page. So if you use this in combination with alignment using surface align wide, you can get higher performance 6 degree of freedom transform. So if you have an X angle or a Z angle, you would prefer using this approach because this tool can operate faster than using the transformation on the scan page. Just illustrating the improvement in accuracy, if you had poor alignment where you were just not appropriately aligning with the Z offset, for example, you might see a step like this. If you have 2 sensors here side by side, it might result in this sort of a seam in where the sensors overlap. And if you have good alignment using the new tool, you might see something closer to this where that plane is simply flat. So just another reminder that all of these tools operate specifically with PC acceleration. So these do not currently operate on GoMax and also not on sensor. They will probably never be supported on sensor just because the operations involved in the transformation are quite CPU intensive. So just performing this 6 degree of freedom transform to that accuracy is quite CPU intensive. So it will probably never be supported directly on sensor, at least in the near future. But we are talking about supporting it on GoMax very soon. So you can look forward to that. But for now, all of this that I talked about in this slide so far requires PC acceleration. I'm just going to quickly check whether there are any questions in the chat. Looks like nothing so far. But just a reminder, if you want to ask anything, just type it into the chat, and we'd be glad to answer it.
I do actually have a question
for
you, if I could. The mesh alignment and transformation tools look amazing, really exciting that it's going to speed up all the processing. I assume that our customers, partners, distributors can get these alignment targets. So the pyramid and also the 9 flat pyramid piece, they just reach out to their local sales reps.
No, we won't be selling the targets. You do have to build it yourself, but we have the CAD included in the utilities package. So you'll find a reference to that in the manual as well. The manual will guide you through the first of all the selection of the appropriate alignment method for your application. So we really expanded the documentation around that in the manual. And it also includes a reference to the CAD, which you can find in the utilities package. So we do have drawings that serve as an example, but the difficulty with supplying alignment targets is that everybody's configuration is going to be different, so that the spacing between their sensors might be different, and you do have to tailor your alignment target to your sensor configuration and the field of view of your sensors. So currently, these are the alignment targets are something that you would build yourself. You can 3D print them if you have an accurate enough 3D printing service that you can use. But yeah, that the expectation is that you would custom build these alignment targets for your application and your specific sensor arrangement.
Excellent. Thank you. That's good to know.
Okay, so I'll move on to the biggest new tool that we're introducing. It's called the Surface Pattern Matching tool. This tool is really replacing what we had so far in the model page. So you may be familiar with the functionality that we have in the model page currently. It allows you to define a model based on edges of your part. So you can add a current scan where it detects the edges and performs matching based on that. But there were a lot of limitations around this. It was not really suitable for partial parts. It was always expecting to see a whole part. So both your template and your subsequent scans would need to be a full view of the full part. It couldn't find multiple instances of a model. It was only designed to find one instance of a part at a time. And it only ever matched against a single model. So if you wanted to have matching against different types of parts in a single job, there was no ability to do that. You would have to switch jobs to be able to match against different parts. There was also no flexible pre-processing. The only pre-processing that you could have on your scan data was on the scan page, the filters, but you couldn't use something like the new Surface Filter tool to do anything more sophisticated for filtering before you perform the matching. So you were limited in that way as well. It also was difficult to set up with anchoring, and it could be fairly fragile. Or sorry, if you used anchoring instead of the model page, that would be another way of dealing with part orientation variations, but that was difficult to set up, and it can be fragile in some cases too if you can't anticipate all the possible orientations of your part properly. So with the Surface Pattern Matching tool, this is contour-based 3-degree of freedom matching. So it is in some ways similar to the way the model page matching worked, but it was actually rebuilt from ground up based on another library. And this is basically completely from scratch, new algorithm that is much more powerful. So one of the key things is that it can operate on multiple instances. So if you have multiple instances of the same part within a single scan, you can locate all of those. You can match multiple models. So you can just have multiple instances of this surface template matching tool, and each of them can be configured with a different model. And that allows you to match different models with these different instances of the tool, all within a single job. It allows variable scale, so you can even tolerate changes in the dimensions of your part. If it's growing or shrinking a little bit from one scan to the next, it can compensate and even measure that as well. And you can pre-process with other tools, because this is just a tool. You can chain in any other tools before the matching process. So that gives you a lot of flexibility. Specifically, surface filter is something that I could see some people using prior to using the surface pattern matching tool. So with this tool now, mesh, surface, and profile all have template matching tools. So you can count on having some sort of comparison or a template matching tool in any of these data types now. So you can locate multiple instances, as I was just saying. So here on this circuit board example, we found 3 of these small resistor components. So it does that quite nicely, and will give you the orientation and match quality measurements for each of those parts. Another example on a circuit board with capacitors, and here an example of the variable scale. It's not very clear here, but there is a difference in the dimension of these buns that are being scanned here, and it's matching, not only matching against each of these parts, but also measuring the scale and giving you a fit, even if the part size does not match perfectly. And then just showing how you can deal with partial occlusion. This part is set up to not be completely in the field of view of the sensor, so it's moving out of the field of view of the sensor. But as we move on to subsequent scans, you can see it can still match successfully against the template drawn in blue here. And on the right-hand side, we're just showing how you could use that. You could perform a surface transform and keep the part perfectly in the same orientation with every scan, just by performing the transform based on the output of the surface pattern matching tool. So as I step through here, you can see there's really no shift at all in the image on the right-hand side, because it's properly tracking the tool, properly tracking the part. So yeah, this is really a very powerful tool. We expect to see a lot of use of it. And it doesn't take a lot to become familiar with it. You really just have to perform a scan, create a model based on your scan, and then you'll see it draw the outline of the part that it's detected the edges on. And then you can change your region to, for example, go from just seeing a small part of your surface to see the whole part, and then perform matching on that. It's quite easy to get up and going with that. And then if you need to tweak your results further, we've also included a new utility in the utilities package. So this is a Windows application that allows you to edit your model as well. So you can actually edit the model that you've generated from the tool, and add and remove edges, change the detection thresholds, and just perform any other edits directly with the part in the field of view here in this separate tool. So that allows you to just perform additional editing that might not be possible within the UI itself. You can do that here. And I would say in most cases, you might not need this at all. This is just for cases where you do want to tune your model further to increase your your matching quality. Okay, then for additional tools that we're introducing, we are adding profile filter, mask, and transform tools. So if you're familiar with the surface mode tools, surface filter, mask, and transform, these are really analogs to those. So profile filter allows you to perform a variety of different filter operations. Profile mask allows you to mask out certain regions of your profile with a rectangle or polygon. Surface profile mask only allows you to mask with a rectangle or a circle, but allows you to do that now in profile mode. And then profile transform allows you to perform rotation and translation based on feature input or any fixed transform, similar to the surface transform tool. We're also adding the surface cylinder tool. It does exactly what you would expect, performs a cylinder fit on the data within the region. So this is a lot more generic than what we've supported in the past using the stud tool. You can still use the stud tool, of course, if you're looking at studs. Typically, when you're looking at a stud, you're looking at it from the top down and sticking out towards the sensor. So that's appropriate for that specific case where you see the surrounding area and you might want to measure the angle of the stud relative to the surface. This is more general purpose where you typically be looking at the cylinder from the side and you get the side wall of the cylinder surface. In that case, you don't need, so for this tool specifically, you don't need any surrounding area. You're just looking at the area of the cylindrical surface itself and performing the fit to that. So this is one of those tools where we've had many requests for it over time. Finally, we got to adding it, and I hope that it will be useful for many different applications. Okay, next big feature that we're introducing is the GoHMI SDK. So this is a SDK application that allows you to create an HMI using Visual Studio. So it does require programming. This is not a HMI, what you see is what you get kind of interface where you drag and drop buttons into the UI. This is still a programming approach to adding UI functionality. But it does allow you to save a lot of time in constructing an HMI, because previously what you would have had to do if you were building a custom HMI, and specifically if you wanted to add a 3D visualization to your HMI, you would have had to do a lot of work getting some sort of 3D visualization in there. So this gives you a lot of a big head start basically on creating an HMI, because we've solved the problem of getting a 3D visualization or a 2D visualization into an HMI for you. It's all open source, with including a sample application. So with this combination of sample and the library, it really makes it a matter of a day or two to just put together. You can start from a sample that we have, and a programmer can put together a custom HMI with whatever measurements you may want to highlight, buttons that you commonly use. If you only perform snapshots, for example, you could have a button for that and make that large in your user interface. It really gives you all that flexibility of creating an HMI, and it saves you all the time of not having to figure out how to create 2D or 3D visualization of the scan data from the sensor yourself. So it's a big time saver, but I just want to emphasize that this still does involve some programming, so you would need to have a programmer to be able to tap into this. Okay, the next feature that I want to talk about is translucent material support. So for a long time, we've had applications that are looking for seeing and measuring the top surface of a material that actually is partially see-through. So in this case, we're not talking about transparent surfaces that you can see through completely, but translucent material that scatter the light within them. So glue is one example. You may have an application like this where you're inspecting a glue bead around the edge of a part, and you're looking for breaks like this in the glue surface. But if you try to scan this with our old spot detection technology, you may end up with results like this, where the red points are the surface height that is being detected on the scan data. And this is simply because in the previous spot detection methods that we have given you, easily accessible through the UI, it would find the highest point in the fit Gaussian for each of these columns. So it would be performing a center of gravity based approach and finding the spot, but really using all the data within this region here. So this is the glue bead here applied on top of a surface, and this is an example of how it would fail because it's not really finding the top surface of the glue that you want to inspect. Everything else here is fine, but in this glue region, it's not doing well. So with translucent spot detection, it allows you to actually get the points on the top of the glue bead, which is what you're looking for. So instead of looking for the center of gravity, we have the ability with this new approach to first of all detect which region of the surface is likely to be the glue surface or the translucent material. We find that based on how wide the spot is for each column. And so if it exceeds a certain threshold, then we say, okay, this must be the area that is translucent. And then we use a point that's closer to the top and use that for the detection of the height. So this is supported on all 2400 and 2500 sensors. We've added the translucent option under the advanced panel. That actually shows up in the spot selection type. So just look under this spot selection dropdown for a translucent. And when you select that, it will use the translucent spot selection method. Just note that this does require a significant CPU, so this isn't something that you would typically want to perform on the sensor. You would typically want to use it with GoMax or GoAccelerator on a PC because it does consume a significant amount of CPU. So to get to higher frame rates, you would typically use a PC acceleration or GoMax to get over a kilohertz, for example. Yeah, that's pretty much my last feature that I wanted to discuss. So we have more time for questions here. Like we said earlier, feel free, don't be shy, type into the chat. You can break the silence there. Yeah, we're open for any discussion. Oh, yeah. I saw one question just come in. Yuki, difference between top and translucent of spot detection. So no problem. I didn't actually tap into that. So the difference between top and translucent is that when we're talking about top, it's actually for the case that there are multiple spots in a column. So if you had a case here, I'm just trying to look for a region of this image that might illustrate this best. If you had your spot detection set up to detect this area down here, you can see that there's a slight spike in the intensity here. And if this was detected as a spot, you would have two spots in this column. You would have one down here, and then, oh, yeah, great, thanks. I'll just draw around here if I can draw. I just need to set the color. I'll just use...
Set the color to yellow. Let's see.
Yeah, I'll just use green here. So if you were detecting a spot down here, and in the same column detecting this spot up here, the top would always prefer the topmost of these two spots. So that's different from the case where for a specific column in this region here, the spot is just very wide. So the beginning and end of the spot might be from here to here. So that's a single spot. And then within that spot, it's about where we report the actual center of the spot. And with the previous spot detection method, we would find it within the center of gravity of all the intensity values here. So it would be somewhere around here. And then when you switch to translucent, it's looking at the spot width. It's actually going from left to right in here. It sees all of these spots here might be below a certain spot width threshold. So we're just using the traditional approach there. But then here it sees, okay, the spot width is very high. So it switches to the translucent spot detection mode, sees that this is very wide, and then prefers the spot closer to the top. So it would find the top edge here of the surface. So you end up finding this. So that's the difference between using top and translucent. It's really about whether you have multiple spots in a column or not. And for translucent, we're still only operating on a single spot per column. And I see there's another question here. Any older features removed? No, we're not removing any features in this release. Compatibility-wise, it stays the same as with 6.0. So there's no features that are being removed. I guess that the context in which this comes up probably is you might be thinking about the model page, because we're adding the surface pattern matching tool. We're still keeping all the model page functionality in the user interface, but in future firmware releases, we will no longer be supporting the model page. So this will be the model page is basically a deprecated feature in 6.1. In future firmware, we won't be using that anymore. So now all of the functionality that you had on the model page is being replaced by tools. So we expect that going forward, you will use tools to perform all the functionality that you used to have on the model page. So that won't be supported anymore in future firmware releases. But with 6.1, everything is still fully supported.
Questions?
Yeah, so if there's no further questions, then I think we can wrap it up.
Yeah, that was great. Nathan, thank you so much for going through all of this. There's a lot of detail here. Very exciting new developments. Oh,
yeah.
We got one.
Yeah, there's one more question here, so let's take this one as well. Translucent doesn't affect detecting the correct height of base surface, does it? No, it doesn't, because we actually segment the profile into different areas. So you're right. It detects the highest intensity point on glue area. Yeah. So this is without translucent spot detection. So I'll move here. This is where it would actually. This is with translucent spot detection enabled. So it would actually detect the edges of the spot. I'll just switch the color here again to green. So it can actually tell based on the width of the spot. So as it's scanning from left to right, it can measure the width of the spot at every point. And so based on the width of the spot, it will say everything from here to here is using the translucent spot detection. And then everything outside in this direction and this direction, these are using the traditional center of gravity approach. So just because you've enabled the translucent spot detection doesn't mean that these results are impacted, because it can tell the difference between a wide spot and a narrow spot. So there's parameters that you'll set within the translucent spot detection so that you can differentiate between these different areas. So the algorithm, as part of it, segments the profile into regions that use the translucent spot detection and don't.
Yeah, another great question.
Yep.
So I was just going to add, when you're talking about the model page and whether or not it's disappearing, I know a lot of our application engineers are very excited for the surface pattern matching tool. Just
Right.
when you have an application that includes a lot of tools, when you're trying to do some measurements where you have almost 100, maybe more tools, this will significantly cut down the number of tools you have to use.
Yeah. Absolutely. If you've previously been using a lot of tools to find edges and track edges to perform anchoring or perform a transform, this can really save you a lot of work, because with a single tool, with the surface pattern matching tool, you can perform all that matching just within that tool. And I would add that it's probably going to be more robust than other approaches where you're using surface edge, for example, to look at a surface edge in a certain location, because you're probably limiting your region to a specific area. So just because you're comparing more edges against each other in your template versus what you're scanning, it adds a lot of robustness, just because you're using a lot more edges for the comparison. And it should also improve the accuracy as well. So it's definitely something worth trying out for applications where previously you've used a lot of tools to perform anchoring. You may be able to replace a lot of that with just a pattern matching tool.
Mm-hmm. And would you say, because it does replace a stack of tools where you have to anchor and anchor one on top of each other, would it speed up processing as well?
It could. It's going to depend on the resolution that you're scanning with. Like it is performing a lot of edge detection. So it really depends on the resolution, and it depends on what tools you were using previously. So if you were using a lot of tools that consumed a lot of processing to perform that, then you could definitely save yourself time. It really depends on what you were doing. I would say in general, if you are working well with just a single surface edge tool or two surface edge tools, that would probably be faster than using a surface pattern matching tool that's looking at the entire field of view, just because it would be operating on a lot more data. So I expect that would actually be slower. But in some cases, you could definitely be faster using the surface pattern matching tool, and more robust and more accurate, like I was saying earlier.
Very nice. Yeah, these are questions that came up in our last class. That's great. Yeah. Thank you. Excellent. So I don't see any other questions coming in. I think that's given us a lot of information. Nathan, thank you so much for taking the time to explain that and cover this with us. And thank you everyone at home for tuning in. Any last parting words, Nathan?
No, that's about it. I mean, as usual, around the new release, there's going to be a lot of questions. So we've got application engineers that can help you out. So reach out to your newest application engineer around any details. And yeah, we look forward to hearing the feedback on these new features.
That's great. Thanks so much. And thank you everyone home. And we'll see you soon.
Okay, thanks a lot.